Hi, welcome back to chemistry today. Today we have a lab, and the lab today is over density. In the notes we learned density is how much stuff, mass, is in a given amount of volume. So we're going to take mass divided by volume to get our density values. We also learned that there's two different units that we use to measure density, and that's because we have two different units on how we measure our volume. And I'm going to show you both of those methods today. In the lab today, you're just going to see two of the little objects that are in the bag. On your lab paper, you have the data for all of them. So you'll have to do the density for all of the objects, even though I'm just going to show you two. This is my lab partner here, Lillian. She's going to help me out with some measuring and things like that. But your objects that you have in your bag today, you have 9 of them. 9. And it's going to ask you in the lab, so you're still going to read your procedure. And when you read your procedure, it says to sort out your objects into regular and irregular shaped objects. Regular shaped objects are squares and rectangles. So a square has 4 sides.
A rectangle has 4 sides too.
And a rectangle has 4 sides too. So we've got a few squares or rectangles. Here's another square. So we'll sort these out into 2 different piles with our squares and rectangles, regular shaped objects. And then we have irregular shaped objects like the crayon.
Yeah, it's like an oval.
It kind of looks like an oval. We're not going to do the geometry to find the volume of this. We're going to take a shortcut. I know that you could find the volume of this object as well.
It has no sides.
It has no sides. It's a circle. And then I've got a rubber stopper here, a rock, and a little flattened marble. So I've got 5 objects that are irregular shaped, not squares or rectangles, and then 4 that are regular shaped. For the first line of your lab, it asks you to find the mass of all of these different objects. So I've got a balance here. It's going to look crazy right now because it's up and down. I'm going to put the object onto the balance, and when you put the object onto the balance, it's going to tell us how many grams mass. Remember, mass is how much matter is in something, how many grams it weighs. So we're not going to do this object, Lily. We're going to do this one. So we're going to do the rubber stopper for our irregular shaped object, and we're going to do our domino for our regular shaped, irregular shaped. We're going to go through the regular shaped object first. So first we're going to put it onto the balance. And when we put it onto the balance, it's going to tell me how many grams this is. This data is already on your lab paper. But this one says it's 13.96 grams. Whenever we write down numbers in data tables in this class, you always want to make sure that you have a unit attached to your number. So I'll write down 13.96 G for grams on my lab data, but yours is already given. For my my irregular shaped objects, Lillian just put it onto the balance, and it says that it has a mass of 6 grams. So again, that's already on your lab paper, but finding the mass is just using a balance and writing down that number in grams. The second component for finding your density is to find the volume. There's 2 methods on finding volume. The first one is for regular shaped objects. For your regular shaped objects, you're going to use a ruler. When we use the ruler, we're going to measure in centimeters. When we measure in centimeters, we're going to find out the length, the width, and the height. Length times width times height is my volume. So all that I'm going to do is I'm going to pick one side. I don't care which side you pick as the length, the width, and the height. But you're just going to record that down. Goggles on at the table, Lillian. Safety first. So this says that it's 5.1 centimeters. So I'm going to write down 5.1 cm for my length. And then again for my width, I'm going to do the same thing. I'm going to line it out, and I'm going to write down that value, which looks like 0.8 of a centimeter. And then the length times the width times the height I don't have yet, That one looks like 2.4 centimeters. So again, all that data is already on your data table. I'm just showing you how I'm getting that value. So I'm taking length, width times height in centimeters from a ruler, and I'm writing that down. Now for my irregular shaped objects like this rubber stopper, I know that we could do the geometry, but we're going to take the easy way out, and we're going to find the volume of this rubber stopper by using water displacement. So this is a graduated cylinder. We're going to put water into my graduated cylinder.
Now put this inside and see if it sinks or floats.
No, we're not going to see if it sinks or floats.
Yeah.
We use density to find out if it, hold on. We've used density to find out if it sinks or floats, but we're not going to do anything yet. So in your procedure that you are reading, you're reading the procedure. It says to just pour water about halfway. It doesn't matter how much water we put in there. And we're recording down that value in the data table. So each of your starting volumes might be different, but it doesn't matter because you're subtracting the difference to get the volume of the object that we're measuring. So we're going to take the measurement in milliliters. Goggles on at the lab table. This measures out in milliliters. So right now I'm starting at 64 milliliters. Again, the data in your lab might be a little bit different than what I just poured because I just kind of randomly poured water in here. So I have 64 milliliters that I'm starting with. We're going to take this object and we're going to put it into the graduated cylinder. Yep. And when we put this object into the graduated cylinder, Lillian, does that sink or float?
Sink.
It's sunk down to the bottom. And when that's sunk down to the bottom, that makes the water level go up. So the difference between the two water levels is the volume of just this object. So it went up to 68 milliliters. So 64 and 68, the difference between them is 4 milliliters. So the volume of this object is 4 milliliters. So you're going to subtract the difference to get the volume of just that object. So then all we're going to do is we're going to pour the water back in the beaker. And then this is a beaker.
Oh, can I put
No, that's a regular shaped object. It doesn't go in there. And then we would do the same thing with our next object. We would put the water in, put it in there, and then go from there. Now your task in the lab today is to do the data. So I gave you all of the, that's glass. Can you put it down, please? All of your data is given to you, but you're going to have to do the math. When you do the math, you're going to find the density, and you're going to have to find the volume of the different objects either by subtraction in milliliters, or you're going to have to find it by taking your length times your width times your height to get your centimeters cubed with your ruler. From there, you have a few questions to answer, and you'll just submit that when you're done. And when you are done with the lab, you're done for the day. So if you have any questions about anything, let me know. But again, your data's given. I just wanted to show you the process of what the lab actually looked like. And then from there, you're going to do the calculations, answer the questions, and then submit the lab.